Now let's look at some sample questions here. The first one here, 1A, number 1A, it reads, name the fission products when uranium-235 splits. So we just looked at this in our previous lesson, and those products are barium and krypton. When uranium splits, first of all, there is need for a neutron. A neutron hits the uranium atom, and then the products are barium and krypton, which are the fission products, the main products. So, but there are also other things. More neutrons are also produced and energy is also released. But when they want the fission products here, they want the main ones. So the main fission products when uranium splits are krypton and barium. They just wanted you to name them, not writing the equation. So understanding a question is a part of an examination. When you understand the question, what does the examiner want? The examiner says, name the fission products. So don't write the equation, just name them. So 2 marks, which means each one is 1-1. The second one says, study the fission reaction below. So there is an equation below. You are supposed to study it carefully. And then after that, you can answer the following questions. 1, find the values of A and B. And then the last one is to name X. So let's first study the equation. Here is the equation the examiner is talking about. Uranium-235, atomic number 92, mass number 235. When a neutron hits it, what happens? That's why they are saying plus. This is related to what we have just talked about. You see, you end up with the barium, you end up with the krypton, and then 2x. This X has atomic number B and mass number A, which we are supposed to establish. So the question says, after studying this, by the way, this equation answers even our first question. When uranium splits, this is uranium, this is a neutron. When a neutron hits the uranium atom, the products are barium and krypton, and these are the answers here. They want us to name the products, barium and what? Krypton. So now, we are supposed, in our next challenge, we are supposed to find the values of A and B. Now, you have already seen that all these things, they have mass numbers and atomic numbers, except which ones? When you look at the equation, you realize that this one has atomic number 92, mass number is known. Atomic number is known 0, mass number is known. These ones are all known, these are all known. So the only unknowns are A and B. And this is what the examiner wants us to get. You can see this question. Find the values of A and B. So what do? We are going to balance the equation. And how do we balance the equation? We are going to look at the mass numbers alone. Mass numbers, that is the top part. The atomic numbers are these ones down. So let's begin with the upper part. When you add 235 plus 1, you get 236. You see? You get 236. Then when you add this, so we shall say, you see this 2. 2 multiplies A. Because the 2 is in front of X, means it is 2X. So we shall say 2 times A, which is actually 2A. When we add it to 90, and then we add it to what? 144. That is the total. The mass numbers on this side must be equal to, we cross the line, must be equal to 1 plus 235. And I think that's what we write here. 2 times A, which is 2A, plus 90 plus 144 is equal to 235 plus 1. We add all the top ones here, must be equal to all the top ones here. So when you add this 235 plus 1, you get 236. When you add 90 plus 144, you get 234. So you end up with what? 2a plus 234 is equal to 236. Now we collect the like terms. Since this one has a, we leave it alone. These are numbers, we put them together. So we shall take this one, this side. And when it crosses the equal sign, it becomes what? A minus. So we shall have now 236. When this one crosses, it becomes minus 234. Meanwhile, this side 2a remains. And when you subtract this, 236 minus 234, you get 2. So we shall have 2a is equal to 2. Because we are interested in a, we divide both sides by 2. And our a will be equal to 1. Okay? Now, does the answer have units? No. Why doesn't it have units? Look at where a is. A is up here. It is just like this one is up. Do they have any units? No. So you just write the answer. You have got a is equal to 1. How many marks were awarded here? There were 2 marks which were awarded. So how does the examiner divide these marks? How do you get all these marks? Remember, at the end of the day, you need to get all these marks. So we shall give a half a mark. Yes, remember these are 2 marks. We shall give a half a mark for balancing the mass numbers this way. When you add is equal to the mass numbers the other side. Then we give a half for the correct answer. So this gives us 1 mark. Then remember, we are supposed to get the values of a and b. Then we also do the same for b. So where is b? B is down here. This 2 is in front of b. So 2 times b is 2b. So 2b plus 36 plus 56, then we cross the equal sign, is equal to 0 plus 92. So, and that is what we write here. 2 times b is 2b plus 36 plus 56 equals 92 plus 0. Now, when you add this 36 plus 56, you get 92. So 2b plus 92. When you add 92 plus 0, you also get 92. So 2b plus 92 is equal to 92. Then you collect the like terms. You make this 92 cross. Here it is having a plus sign. When it crosses, it becomes minus. So you end up with the 2b is equal to 92 minus 92. 92 divided by 92, you get what? 0. And you divide both sides by 2. So your b is equal to 0. Also, we shall give 1 mark, a half a mark here, and a half a mark for the answer. So the total marks for calculating b is 1. The total marks for calculating a is also 1. 1 plus 1, you get what? 2. So you end up getting all these 2 marks. Then lastly, part B, Roman 2 says, name x. Now where is x? You look at this equation here. When you look at this equation, x is this one. The unknown here is what? Here. So what do? Since you have already known the values of a and b, so you're right. Our a we got was what? What was the answer for a? Small a is what? 1. Then our b, we have just calculated, is what? 0. So this one is supposed to be 0, this is supposed to be 1. So what is that element? What is that thing which has atomic number 0 and a mass number 1? And the answer is here. It is a neutron. When the top part, the A, the upper part, once you see it is what? 1. Although here they have pretended it to be A. But when you calculate the upper part and you find that it is what? 1. Then you calculate the downer part, you find it is what? 0. Then you know you are dealing with what? A neutron. So for us, this examiner wants us to name X. So after knowing the atomic number and the mass number, you simply say X is called a what? A neutron, and you get your answer. Now let's move on to uses of nuclear energy. From the word nuclear, it means we are talking about the nucleus. By the way, there are 3 main sources of nuclear energy. We have fusion, releases energy. Fission also releases energy, and also radioactive decay. Now, this nuclear energy can be used in daily life. Where do we use nuclear energy? The energy which is produced as a result of fusion, and radioactive decay. We can make the best use of this energy. Where do we use them? One, that energy can be used in producing atomic bombs. We can use it to produce atomic bombs. We can also use it to generate electricity, and we can also use it as a fuel in some space rockets. Okay? So we use that energy in atomic bombs to generate electricity, and we can also use it as fuel, especially by some space rockets. Now, where do we use radioactivity? Applications of radioactivity. There are so many uses. The uses could be medical uses, biological uses, and so on. Let's look at the medical uses of radioactivity. Radioactivity is used to treat cancer. We also use radioactivity to treat goiter. You know, that swelling which is always on the thyroid due to lack of iodine is called what? Goiter. So we use it to treat goiter. We also use it in radiotherapy. We also use it in radiotherapy. Then we can also use it to sterilize medical instruments. So a number of times when you go for treatment in a hospital, you realize that the bandages which they use, the other medical instruments like syringes which they use for injection, they look very fresh. Why do they look very fresh? It means they were properly stored, and they had to sterilize them so that they are free from germs. So how do we sterilize those medical instruments so that they are free from germs? We use radioactivity to do that. So briefly, these are some of the medical uses of radioactivity. We are going to proceed to look at other uses. Apart from medical uses, we have also other uses. So when somebody says, state 2 medical uses of radioactivity, simply say radioactivity is used to treat cancer. It can also be used to treat goiter. We also use it in radiotherapy. And we can also use it to sterilize medical instruments.